Everything you know about time might be an illusion. We are about to venture into the profound and perplexing world of time travel and causality, a cornerstone of space mysteries that challenges our very understanding of existence. By the end of this journey, you will see the fabric of reality in a completely new light. We will explore whether you could stand face to face with your past self, and what happens if you try to erase a single moment from history. We are embarking on an epic exploration of 30 mind-bending theories, from the rigid laws of physics to the wildest realms of philosophy, that reveal how time might flow, bend, and even break. What do you believe is the most dangerous idea a time traveler could bring back? That single question is a trapdoor into the deepest mysteries of the universe, and it all begins with a rule so fundamental we rarely even notice it. Causality is the silent engine of reality. It is the simple, undeniable truth that for every action there is a reaction, for every effect, a cause. You do not find a shattered window without a thrown stone, a fallen tree without a fierce storm. This chain of events flows in one direction, from past to present to future, creating the river of time we all swim within. We call this the arrow of time, and it feels as absolute as gravity. But what if this arrow is not a fundamental law of the cosmos, but merely a habit, a pattern so consistent we mistake it for truth? Ancient thinkers like Aristotle framed it as the essence of change in the natural world, while philosophers like David Hume famously questioned whether we could ever truly prove that one event causes another, or if we are simply observing a sequence of events our minds have learned to connect. This foundational doubt is the first crack in the wall, because if causality is not an unbreakable chain, then the door to tampering with time is already ajar. The moment you consider stepping back to prevent that thrown stone, you are challenging this bedrock principle. You are asking what happens to the window if the stone never flew. This is the birthplace of every time travel paradox, a conflict between the world as we know it and a world where effects can precede their causes. To journey into the theories that follow, we must first appreciate the weight of this rule we are about to test. The entire structure of our experience, from memory to consequence, is built upon it. That foundational crack in causality leads us directly to our first and perhaps most humbling theory, a concept designed to seal that crack shut forever. It is called the Novikov self-consistency principle, proposed by the Russian physicist Igor Novikov. This idea presents a universe with an impeccable sense of order, one that protects its own history from the chaos of paradox through a simple, elegant rule: logical consistency. According to this principle, any actions taken by a time traveler were always a part of history. You cannot change the past because you already did whatever you did. The timeline is a single, unchangeable thread. Your journey back is not an intrusion, it is a return, a necessary component of events that have already unfolded. This transforms the idea of time travel from an act of rebellion into one of participation. Think of it like this: you read about a famous library fire in the history books. Driven by a love for knowledge, you build a time machine to go back and save the precious manuscripts. You arrive in the past, locate the library, and as you rush inside to warn everyone, you accidentally knock over an old oil lamp. The flame catches a curtain, and before you can stop it, the very fire you came to prevent is raging, started by your own hand. In this closed loop, your attempt to change history was always the cause. Your free will felt real in the moment, but your actions were seamlessly woven into the tapestry of what was always meant to happen. The Novikov principle argues the universe simply would not allow any other outcome. Physical laws would conspire against you. A gun might jam, a warning might be misunderstood, a path might be blocked, ensuring you fulfill your role in the predetermined sequence. This eliminates paradoxes beautifully but at a profound cost. It suggests that within the context of time travel, our choices may be an illusion. Our futures might be already written, with our past selves merely playing a part we have not yet read. It forces us to ask, if we could travel in time, would we be authors of our destiny? Or are we just actors reciting lines from a script we helped write long before we were born? But if the universe is a single, unchangeable script, where does that leave our sense of possibility? The Novikov principle offers a clean, paradox-free universe, yet it feels strangely restrictive, like a story with only one ending. For a more expansive vision, we must look to the strange rules that govern the smallest particles in existence. From the realm of quantum mechanics comes a theory that does not protect a single timeline, but shatters it into infinite reflections. This is the many worlds interpretation, proposed by physicist Hugh Everett. It suggests that every quantum event with more than one possible outcome does not choose a single path. Instead, the entire universe splits, branching into parallel realities where each possibility is realized. A single particle's random spin does not collapse into one state. It spawns two universes, one where it spun left and one where it spun right. Now scale this up from particles to people. Every choice you have ever made, every chance event, from a missed bus to a spoken word, did not just happen one way. In another, nearly identical universe, a different version of you made the opposite choice and lives a different life. This transforms time travel from history editing into universe hopping. If you were to go back and prevent a tragic event, you would not be rewriting your own past. You would be stepping sideways into a new, branching timeline where that event never occurred. Your original timeline, with all its history and heartache, continues unchanged. You have not erased your own pain. You have simply created a new reality where a version of you does not have to bear it. This elegantly dissolves every paradox. Could you meet your past self? Absolutely, but it would be a version of yourself from a newly created branch, not the one you left behind. Could you accidentally prevent your own birth? Only in a new, separate universe, while the you that embarked on the journey remains perfectly intact in your original world. The many worlds interpretation paints a cosmos of staggering abundance, a multiverse where every dream, every regret, every road not taken is being lived out in full color somewhere else. It offers a breathtaking solution to causality by making every cause produce not one effect, but an infinite bouquet of them. It asks us, if every possible version of our life is real, does that make our choices more meaningful or render them utterly insignificant? The idea of infinite branching realities offers a dizzying freedom, but it asks us to surrender the solid ground of a single, shared history. For a perspective that feels even more alien to our daily experience, we must turn to a model that emerges not from quantum speculation, but from the rock-solid equations of Einstein's own theory of relativity. This is the block universe, a concept sometimes called eternalism. Imagine not a river of time flowing from a source to a sea, but a vast, frozen sculpture. In this model, the past, the present, and the future do not happen one after the other. They all exist permanently and simultaneously, like every frame of a film stored on a reel. Your birth, you listening to this now, and every moment of your future are all equally real, fixed points in a four-dimensional structure where time is just another direction, like length, width, and height. Einstein's work showed that the experience of now is relative. It changes depending on how you are moving through space. There is no universal present moment that everyone shares, which means the distinction between past and future is not a fundamental feature of the cosmos, but a feature of our perception. In the block universe, time travel loses its magical quality. To journey to another year is not to rewrite history or jump to a new branch. It is simply to move your awareness to a different, pre-existing location within the grand, static block. You are not changing the story, you are just turning to a different page that was always there. This has a profound and unsettling consequence for our sense of self. It challenges the very notion of free will and genuine change. If the future is already out there, complete and waiting, then are our choices real, or are we merely following a path that is already etched into the fabric of reality? Our lives become like scenes in a film that has already been shot in its entirety. We experience it moment by moment, believing in the drama of what comes next, but the entire narrative from opening credits to final scene exists at once. This invites a haunting question: is our journey through time, with all its anxiety and anticipation, merely an illusion crafted by our consciousness? Are we not the authors of our tale, but readers discovering a book that was written long before we open the cover? The block universe offers a majestic, if deterministic, vision of reality, one where every joy and every hardship is a permanent part of the cosmic landscape, forever locked in its place. That frozen block of a universe presents a reality where everything simply is. Yet within its static geometry, the equations of general relativity permit a strange and twisted possibility, a path that curves back on itself so completely that it erases its own beginning. This is the Bootstrap Paradox, a loop with no origin. Imagine an object, a piece of information, or even a person that is sent back in time, only to become the very cause of its own existence. It is a closed circle of causality with no starting point, a mystery that was never created, only perpetuated. The classic example involves a time traveler who is a great admirer of Beethoven's symphonies. He travels back to the early 1800s, meets a young Beethoven, and hands him a meticulously printed book containing the sheet music for all 9 symphonies. The inspired young composer then simply copies the music and publishes it under his own name, becoming famous for works he did not originally compose. The music exists, it is beautiful and real, but it has no author. Who created it? It was not Beethoven who merely transcribed it. It was not the time traveler who received it from the historical record. The information has no point of origin. It is an uncaused artifact trapped in an endless loop, forever its own source. Physicists describe this as a closed time-like curve, a path through warped spacetime that allows something to interact with its own past. This is not science fiction, but a serious mathematical consequence of Einstein's field equations under extreme conditions. The paradox forces a profound philosophical question: where do things truly come from? Could certain ideas, melodies, or even technological blueprints in our history be these timeless loops? A discovery made tomorrow might be the very inspiration mailed back to a genius of the past, creating a legacy with no true inventor. It challenges the very foundation of knowledge, suggesting some elements of our culture might not have a linear history, but are instead self-sustaining echoes traveling through time. This leads us to an even more unsettling loop, one that targets the traveler's own identity. The most chilling question a time traveler could ask is not about changing history, but about erasing themselves from it. This is the grandfather paradox, the ultimate logical trap. You travel to a time before your parents were born, and you prevent your own grandfather from ever meeting your grandmother. Without that union, your parent is never conceived, and therefore you are never born. But if you were never born, you could not have built the time machine, made the journey, or interfered with your ancestors. So, who stopped the meeting? The act unravels its own possibility, creating a contradiction that seems to shatter the very logic of reality. It is the classic, terrifying proof that changing a single event in a single, unified timeline is impossible without breaking causality into nonsense. This paradox is not just a puzzle, it is a profound clash between two human intuitions: our belief in free will to change things, and the universe's apparent demand for consistent physical laws. If you truly have the freedom to go back and pull that trigger, then physics must allow for an effect, your non-existence, that obliterates its own cause. The universe, it seems, cannot tolerate such a contradiction. Different theories offer their own escape routes from this impossible loop. The Novikov self-consistency principle we discussed earlier would assert that the universe simply will not let you succeed. Your gun will jam, your grandfather will duck, a sudden noise will startle you. Any physical event will conspire to ensure your ancestors meet, preserving the timeline that contains you. In this view, your free will is an illusion within the context of the journey. You were always destined to fail. The many worlds interpretation, however, provides a dramatic exit. The moment you interfere, the timeline splits. In one branch, your grandfather's life continues unchanged, and you are born. In the new branch you have created, he never meets your grandmother, and a version of you is never conceived. You, the traveler, are simply a visitor from another reality, watching this new world unfold without you. You haven't erased yourself, you have just become a ghost in a history that is not your own. The grandfather paradox forces us to confront the price of power over time. It asks whether true change is a gift or a curse, and whether preserving our own existence means the past must remain forever locked, a story we can read but never edit. The paradox of erasing yourself from history forces us to examine the very pathways through spacetime that could make such a journey possible. Deep within the elegant mathematics of Einstein's general relativity, there exists a strange and wondrous possibility, a loophole in the architecture of the cosmos. These are closed time-like curves. To understand them, picture the universe not as a static stage, but as a dynamic, flexible fabric, warped by mass and energy. A world line is the unique path an object takes through this four-dimensional fabric. Normally, this line moves ever forward in time, like a single thread woven through the cloth. A closed time-like curve is a world line that bends so severely it loops back and intersects its own past, creating a circle in spacetime. An object following this curve would not be breaking any speed limit. It would simply be following a natural, if profoundly twisted, road laid down by the geometry of the universe itself. In theory, you could embark on such a journey and, without ever exceeding the speed of light, find yourself arriving at the very moment you left, or even before. This is not a machine built in a garage, but a feature of the cosmic landscape, a mountain passed through time that exists if the conditions are extreme enough. Physicists like Kurt Gödel and later Frank Tipler showed that such curves could form around infinitely long, rotating cylinders of immense density, or in the presence of exotic forms of matter with so-called negative energy. While we have no evidence these conditions exist or are even possible to create, their mathematical reality is a staggering revelation. It means time travel is not explicitly forbidden by our most successful theory of gravity. It is merely hidden behind barriers of almost unimaginable scale. These curves transform time from a one-way street into a potential racetrack, a loop where cause and effect can chase their own tails. They provide the physical blueprint for the Bootstrap Paradox, a tangible mechanism for information or an object to become its own origin. Exploring these curves is like finding a secret door drawn on the blueprints of reality, a door we cannot yet open, but whose very existence changes our understanding of the house we live in. It challenges the linear flow we feel in our bones, suggesting that on a cosmic scale, time might be far more flexible and far more strange than our everyday experience allows us to see. Stephen Hawking looked at the dizzying possibilities of closed time-like curves and asked a profoundly practical question. If time travel to the past is even remotely possible, where is everybody? The absence of tourists from the future, a point he noted with characteristic wit, seemed to him like powerful evidence that something fundamental is in the way. From this observation, he formulated the chronology protection conjecture, a kind of cosmic safety protocol. Hawking proposed that the laws of physics, particularly the wild and unpredictable rules of the quantum realm, contain a built-in mechanism that prevents the formation of macroscopic time machines. Think of it as the universe's own paradox prevention software. The conjecture suggests that whenever conditions arise that could twist spacetime into a closed time-like curve, something always intervenes. Just as a time machine is about to be created, a surge of quantum energy would flood the region, or the very fabric of reality would become unstable, collapsing the possibility before a single paradox could be born. It is not that time travel is mathematically impossible in Einstein's equations, but that nature actively conspires to make it physically impossible. This idea transforms the question from a technological one into a philosophical one. It posits that causality, the clean flow from cause to effect, is not just a pattern we observe, but a principle the universe is hardwired to protect. The arrow of time is not merely a feature, it is a guarded rule. Hawking's conjecture offers a clean, almost comforting answer to the Fermi paradox of time travel. We have not met visitors from tomorrow because the cosmos itself erects a barrier at the boundary of paradox, a wall of quantum fire or gravitational feedback that preserves the integrity of history. It suggests that our timeline is safe, not by accident but by design, shielded from meddling by the fundamental laws that govern reality. This leads us to wonder, is the protection of our past the universe's highest priority? And if so, what other cosmic rules are being silently, vigilantly enforced? Hawking's cosmic safety protocol protects a linear history, but what if the timeline it guards is itself an illusion? This brings us to a theory that challenges the very existence of time as we know it. Some of the most radical ideas in modern physics propose that time is not a fundamental ingredient of the universe. It is an emergent property. Think about the concept of temperature. You can touch a hot stove and feel its heat, but that heat is not a fundamental substance. It emerges from the frantic, collective motion of trillions of invisible molecules. The heat is real to your senses, but it is a consequence of something deeper. Now apply that same logic to time itself. Pioneering theories like loop quantum gravity and certain branches of string theory suggest that what we perceive as the relentless flow of time might emerge from a more basic, timeless layer of reality. In this view, the universe at its most fundamental level is a vast, frozen network of relationships, a cosmic web of events with no inherent past, present, or future. The sensation of time passing, the feeling that one moment follows another, could be generated by the way quantum particles become entangled with one another, or by the way information propagates through this network. It is like watching a movie. The story feels like it flows from beginning to end, but that flow is an illusion created by the rapid projection of individual static frames. Our consciousness is the projector, stitching together these timeless nows into a coherent narrative of cause and effect. If this is true, then our entire discussion of time travel undergoes a seismic shift. Traveling through time would not be like navigating a river, because the river does not fundamentally exist. Instead, manipulating the flow of events would require reaching down into that timeless substrate and rearranging the fundamental relationships between things. It would be less like steering a ship and more like rewriting the code of the simulation from the outside. This redefines causality in a breathtaking way. Cause and effect are not the engine of reality, but a story that reality tells itself at our level of perception. The deep question then becomes, what is the true nature of the timeless reality from which our world of change and history emerges? Are we, in our journey from birth to rest, simply reading a single, beautiful thread woven through an eternal and unchanging tapestry? The timeless tapestry from which our reality emerges presents a profound mystery, but within the story our consciousness weaves, certain events seem to carry a terrifying inevitability. This is the Predestination Paradox, a cruel and elegant twist of fate where every effort to change history only tightens the knot. Unlike the Grandfather Paradox, which creates a contradiction by erasing the traveler, the Predestination Paradox creates perfect, maddening consistency. Your journey to the past does not alter the event you fear. It becomes the very reason that event occurs. History records the outcome, and your desperate attempt to stop it is the invisible, essential ingredient that makes the record true. It is a loop with no escape, only the illusion of one. Consider a classic tale. A young artist reads in an old newspaper about a tragic fire that destroyed a beloved museum and its priceless paintings. Haunted by the loss, they build a time machine. They arrive in the past, locate the museum, and in their frantic search for the source of the future blaze, they accidentally knock over a lantern. The flames spread, consuming the very art they came to save. The newspaper report they read was not a record of a random accident. It was the first chapter in a story they themselves would finish. Their free will felt absolute in the moment, but every choice led them directly to fulfilling a destiny they believed they were fighting. This paradox creates a stable, self-fulfilling timeline where cause and effect chase each other in a perfect circle. The effect, the time traveler's journey, exists because of the cause, the historical event. Yet the historical event exists only because of the effect, the traveler's intervention. Which came first? The loop has no true beginning. It simply is a closed circuit of inevitability. This blurs the line between choice and destiny in a deeply unsettling way. It suggests that some moments in history might be fixed points, inescapable knots in the timeline that cannot be cut, only woven tighter by the very hands trying to unravel them. It forces us to ask a haunting question about our own lives. How many of our struggles to avoid a certain fate are secretly the steps that lead us directly to its door? That cruel knot of predestination reveals a universe where history is a story we cannot edit, only fulfill. But what if the story itself contains characters and props that have no author? This brings us to the ontological paradox, a mystery that goes beyond events to challenge the very origin of existence. While the Bootstrap Paradox asks where an idea came from, the ontological paradox asks where the physical thing itself began. It occurs when an object, a piece of information, or even a person is sent from the future into the past, where it becomes essential to its own creation or discovery, creating a closed loop with no discernible starting point. The object's entire existence is dependent on the time loop. It has no independent origin in the timeline. Think of a scientist who receives a mysterious, perfectly engineered device from a future version of themselves. Intrigued, they spend years studying it, reverse engineering its principles, and eventually learning how to build it. Once completed, they then send the device back through time to their younger self. The machine exists, it functions, but it was never invented in the conventional sense. Who designed it? The younger scientist learned from the device they received, and the older scientist built it using knowledge gained from that same device. Its blueprints, its materials, its very atoms have simply always been in transit, a permanent resident of a causal circle. This presents a staggering challenge to fundamental laws like the conservation of mass and energy. Where did the mass for that object originally come from? In our normal, linear universe, everything can be traced back to an earlier state, to the Big Bang, to the fusion in stars. But within a closed time-like curve, an object's history is a perfect loop. It has no initial moment of creation. Its mass and energy are not created or destroyed. They are just eternally recycled within the loop, causally disconnected from the rest of cosmic history. It suggests that in a universe permitting time travel, certain things might not have a birth. They just are, eternal artifacts with no creator. Their existence a question the timeline itself refuses to answer. This forces us to reconsider what it means for something to be real. Is an object defined by its point of origin, or simply by its persistent presence in the web of events? Could there be elements in our own world, perhaps a forgotten formula or a strangely advanced artifact, that are not products of our history, but visitors from a loop we have yet to discover? The timeless artifacts of an ontological paradox exist in a perfect, isolated loop, but our own world is a place of profound and fragile connection. The most delicate of these connections forms the heart of the 11th theory, a concept that makes the very idea of meddling with history seem like an act of cosmic insanity. This is the butterfly effect, a cornerstone of chaos theory. It reveals that within complex, sensitive systems, an infinitesimally small change in the initial conditions can cascade into a future that is utterly unrecognizable. The classic metaphor asks if the flap of a butterfly's wings in Brazil could set in motion a chain of atmospheric events that ultimately leads to a tornado in Texas. The answer from chaos theory is a sobering yes in principle. The system of our world is so exquisitely intertwined, so dependent on a near infinite web of causes, that no action is ever truly isolated. Now apply this to time travel. You step back into the past with the purest of intentions. You move a single pebble from a path to avoid someone tripping. That person who originally would have stumbled and met a stranger while picking up their dropped papers now walks on unhindered. The conversation that would have led to a marriage, a family, a brilliant invention, or a crucial political decision never happens. Over decades, the ripple of that unmoved pebble expands, rewriting friendships, careers, discoveries, and wars. By the time you return to your present, you might find a world where your own city does not exist, or where the technology that allowed your journey was never invented. The butterfly effect transforms time travel from a precise surgical tool into a blunt instrument of unimaginable power. It suggests that the timeline is not a sturdy rope you can splice, but a vast, chaotic web where plucking one thread makes the entire structure shudder and reconfigure in ways no human mind could ever predict. There is no fixing a single event because that event is woven into millions of others. The quest to prevent a tragedy could erase the very context that made it a tragedy, or create something far worse from the cascading chaos. This theory installs a profound humility before the machinery of history. It argues that our reality is not just a sequence of events, but a dynamic, sensitive organism, and even the gentlest touch from a time traveler could be a fatal shock to the system. The profound chaos of the butterfly effect reveals a timeline of breathtaking sensitivity. But what if we could bypass history entirely and send a message directly through the fabric of time itself? The quantum realm offers a pathway that defies classical logic, one where information itself can seemingly leap across time. This is the frontier of quantum time travel via teleportation. At the heart of this bizarre possibility are two of quantum mechanics' most mysterious features, entanglement and something called post-selection. Entanglement is the profound link that can form between two particles, where the state of one instantly influences the state of its partner, no matter the distance separating them. It is as if you had two coins, one on Earth and one on Mars, that always land on opposite faces when flipped, communicating their result faster than light. Now combine this with post-selection, a technique where an experimenter only looks at the results of a quantum experiment that meet a very specific, pre-chosen condition. By carefully setting up an experiment with entangled particles and then post-selecting for a particular outcome, some theoretical models suggest it might be possible to effectively send a quantum state, a tiny packet of information, backward in time. The process is not like a time machine in a film. It is a statistical trick played on reality itself. Imagine you want to send a single bit of quantum information, like a yes or no, to your past self. You would perform a complex quantum operation in the present that entangles particles, and through the magic of post-selection, You force the universe to only give you a result that makes sense if that yes or no signal was already received and acted upon in the past. In the successful cases, it would appear as if the effect, your action now, reached back and caused something to happen earlier. This does not mean you could send a person or even a dust mote. The limitations are severe and the success is purely probabilistic, a roll of the quantum dice. But the mere theoretical possibility is revolutionary. It suggests that at the fundamental, subatomic level, the rigid arrow of time might soften. Cause and effect, the unbreakable chain of classical physics, might become a two-way street in the quantum fog. Particles might not always care which moment comes first, hinting that our experience of a linear, flowing time is not a law written in stone, but a large-scale illusion that emerges from the collective behavior of countless particles that themselves are dancing to a far stranger, more timeless tune. The quantum dance, where particles blur the line between past and future, finds its most elegant expression in a theory known as the two-state vector formalism. This is not a story of time machines, but a radical reimagining of how cause and effect operate at the most fundamental level. In standard quantum mechanics, we describe a particle by its state vector, a mathematical snapshot of its properties like position and momentum at a single moment. This snapshot is determined solely by what happened to it in the past, its initial conditions. The two-state vector formalism proposes something far more symmetrical. It suggests a complete description of a quantum system requires not one, but two vectors, one from the past and one from the future. It is as if the particle's journey is not just pushed from behind by its history, but also gently pulled from ahead by its ultimate destination. This framework treats time with a beautiful, even-handed balance, where the present moment is a kind of handshake between what was and what will be. The most startling interpretation of this math is the idea of retrocausality, the notion that events in the future can reach back and influence events in the past. Think of it like a detective story written in reverse, where the final clue determines how the first clue must have been placed. In laboratory experiments, scientists have set up intricate quantum scenarios where a measurement choice made in the present appears to dictate the state of a particle in the past. These are not proofs of time travel, but profound puzzles that challenge the strict, forward-only arrow of causality we take for granted. Within this symmetrical view, a hypothetical time traveler would not simply jump from one point to another. They could exist in a quantum superposition of states, being both here and there, both now and then, until a final condition, perhaps their decision to return home, crystallizes their entire journey into a single, consistent history. This theory does not break the universe. It proposes the universe was never broken to begin with, that our one-way experience of time is a large-scale simplification of a deeper, two-way conversation. It asks us to consider whether the future is an empty page we are writing, or a story that is already complete, waiting for us to turn each page and discover how the beginning was shaped by the end. The symmetrical dance of quantum particles reveals a universe where past and future may converse, but to truly master time, we must first learn to command the vast stage on which it plays out. The 14th theory brings us from the subatomic realm to the grand, cosmic scale of warping the fabric of reality itself. This is the Alcubierre warp drive and its profound relationship with time dilation. Proposed by physicist Miguel Alcubierre, this is not a time machine in the classic sense, but a theoretical method for faster-than-light travel by manipulating spacetime. The idea involves creating a warp bubble around a ship, contracting space in front of it and expanding space behind it. Within this bubble, the ship itself would not be moving through space at all. It would be carried along as the fabric of the universe moves around it, like a surfer riding a wave. This cleverly sidesteps Einstein's rule that nothing can move through space faster than light, by moving space itself instead. The profound connection to time emerges from the core principles of relativity. Any object moving at a significant fraction of light speed or existing within a powerful warp field experiences extreme time dilation. Time for the passenger inside the bubble slows down relative to the outside universe. Imagine a journey to a star 100 light-years away. For everyone on Earth, that voyage would take over a century, but for the crew inside the warp bubble, perhaps only 10 years pass. They depart, complete their mission, and return. When they step out, they find the Earth they left behind has aged 100 years, while they have aged only 10. They have not traveled to the past, but they have leapt decades into the future relative to their home. This is a one-way journey into tomorrow, a form of time travel made possible by conquering space. It demonstrates an inseparable link. To manipulate space is to manipulate time. The causality puzzle here is stark and personal. Two people who share a moment of farewell could, from their own perspectives, be separated by a vastly different flow of time. For one, it is a long career and a lifetime of memories. For the other, it is a single mission. They reunite as strangers from different eras, their shared past now a distant memory for one and a recent event for the other. The Alcubierre concept shows that any civilization with the technology to sail the stars would also hold the key to navigating the river of time, at least in one direction. It frames deep space exploration not just as a journey across distance, but as a voyage through the fourth dimension, where every light-year crossed is also a step into a new future. The warp drive's journey into the future bends the rules of space, but to truly twist time into a loop, we must look to a structure of almost mythical scale. Deep within the elegant equations of general relativity, there exists a solution so specific, so extreme, it reads like an architect's plan for a time machine. This is the concept of the Tipler Cylinder, named for the physicist Frank Tipler. Imagine a cylinder of unimaginable density, as massive as a star but shaped like an endless rod, spinning at a significant fraction of the speed of light. According to Einstein's theory, such a colossal, rotating mass would not just bend spacetime, it would drag the very fabric of the universe around with it, like a spoon stirring a thick fluid. This phenomenon, called frame dragging, is real. We have measured slight versions of it around our own rotating Earth. But around a Tipler cylinder, the effect would be so powerful that spacetime itself would be twisted into a helix. If you were to pilot a ship on a carefully calculated spiral path around this spinning monolith, you could find yourself on a closed Timelike curve, a road that leads back to your own past. You would not be moving faster than light. You would simply be following a corridor in spacetime that the cylinder's rotation has curled into a loop. Similarly, some cosmological models suggest that if our entire universe were rotating, the collective frame dragging on a cosmic scale could weave time loops into the fabric of reality itself, making closed time-like curves a natural feature of the cosmos. While building an infinitely long cylinder of stellar mass is almost certainly beyond any conceivable engineering, the sheer mathematical existence of these solutions is profoundly revealing. They demonstrate that the physics governing our universe does not explicitly forbid travel to the past. It merely hides the blueprints behind conditions of impossible extremity. This suggests something remarkable about causality itself. The arrow of time, the steady flow from cause to effect we experience every day, may not be a fundamental, universal law etched into the bedrock of existence. Instead, it could be a local condition, a feature of the relatively calm, low-energy, non-rotating region of spacetime we happen to inhabit, in a different corner of the cosmos, near a titanic, spinning vortex of mass. The rules of before and after might loosen, and the river of time could flow in a circle. The Tipler cylinder is less a practical proposal and more a cosmic thought experiment, proving that within the boundless imagination of Einstein's equations, the past might not be a country we can never revisit, but a destination waiting at the end of a road we have not yet learned to build. The immense spinning cylinder suggests time can be bent, but what if it cannot be bent infinitely? What if the river of time does not flow smoothly, but ticks forward in the smallest possible clicks, like the second hand on a cosmic clock? This leads us to the 16th theory, the concept of chronons. This radical idea proposes that time itself is not a continuous, flowing stream, but is instead granular, composed of discrete and indivisible packets. These packets, these chronons, would be the fundamental units of time, the absolute smallest interval that can exist. There can be nothing shorter than a chronon, just as you cannot have half a pixel on a digital screen. Our experience of smooth, flowing time would then be an illusion, much like a movie appears continuous despite being a rapid sequence of still frames. If this is true, it reshapes everything about causality and the potential for time travel. In a quantized time universe, events do not unfold in a seamless continuum. They progress in a series of jumps from one chronon to the next. This granularity could impose a cosmic speed limit on change itself, preventing anything from happening in less than one chronon. For a time traveler, this means movement through time would not be a smooth voyage. It would be a process of jumping from one discrete time pixel to another, potentially skipping over the intermediate states entirely. You would not witness every moment of a year. You would leap from the first chronon of January to the last chronon of December in a single quantum bound. This quantization offers a potential resolution to some of the most troubling paradoxes. The infamous infinite regress, where an event requires a prior cause which itself requires a prior cause forever backward, would be stopped in its tracks. There are only a finite number of chronons between any 2 points in time. You cannot divide an interval smaller than the fundamental grain, so the chain of causes must have a starting point within that granular framework. It suggests the universe has a built-in refresh rate, and paradoxes that rely on infinite precision simply cannot be rendered in such a system. Exploring chronons bridges the vast scales of spacetime with the bizarre rules of quantum mechanics, hinting at a digital or computational underpinning to reality. It asks us to consider if the cosmos operates on a kind of cosmic clock cycle, where the flow of time, and perhaps all of existence, advances not as a river, but as the steady, relentless ticking of a fundamental metronome at the heart of all things. The granular tick of chronons suggests a universe with a fixed refresh rate, but what if the entire program is stuck on repeat? From the realm of profound philosophy comes a theory that echoes through the corridors of both thought and science, the concept of eternal recurrence. This idea posits that the universe and every event within it, from the birth of a star to your listening to this now, is destined to recur in an identical form an infinite number of times. In this view, time is not a line or even a branching tree, but an immense closed circle. The cosmos expands, contracts, and is reborn in a big bang once more, replaying the same cosmic script forever. Every choice you make, every joy and hardship you experience, has already unfolded countless times before and will do so again endlessly. This transforms our understanding of causality into something deeply cyclical. In each cycle, every event is both the effect of the previous iteration and the identical cause for the next. The chain of cause and effect does not flow in one direction along a timeline. It spirals, connecting each loop to the next in a perfect, unbreakable pattern. This presents the ultimate challenge to traditional time travel. If there is no linear past to visit, only an eternal present moment that is perpetually recurring, then the very goal of changing history becomes meaningless. You could not alter an event because that event is a fixed point in an infinite loop. Any journey you undertook would itself be a predetermined part of the cycle, a scene rehearsed and performed an eternity of times. This idea, most famously associated with the philosopher Friedrich Nietzsche, was not merely poetic speculation. It finds a chilling resonance in certain interpretations of modern cosmology. If the universe eventually collapses in a big crunch, or if the nature of quantum states is finite, then over an infinite duration, the random shuffling of particles could eventually recreate any given configuration, including this one, again and again. This confronts us with a staggering question about meaning. If our lives, with all their struggles and triumphs, are destined for infinite repetition, does that render our actions insignificant, or does it imbue every moment with an unimaginable weight? Are we living a unique story, or are we actors performing the same play on a stage that has no final curtain for an audience that is only ourselves forever? Eternal recurrence locks us into an endless, identical loop. But what if the cosmos offers not a single repeating track, but an infinite array of parallel destinations? The many worlds interpretation we explored earlier opens a staggering possibility: the existence of temporal refugees. Picture a civilization that has glimpsed its own annihilation, perhaps through an unavoidable cosmic catastrophe or a paradox tearing at the seams of their reality. Their salvation lies not in fleeing across space, but in stepping sideways into a neighboring timeline where that specific disaster never occurred. These would not be time travelers in the classic sense, but dimensional nomads navigating the vast, branching tree of possible histories as one might sail between islands. For a society with such mastery, causality transforms from a linear chain into a sprawling web. A cause in their original world produces not one effect, but a spectrum of outcomes, each realized in a separate universe. Their technology would allow them to map these branches, to identify stable timelines with resources or conditions they need, and to migrate their entire culture into a new strand of history. This reframes the very concept of exploration. The final frontier is no longer just the distant stars, but the adjacent pasts and futures, the countless versions of Earth where a different king was crowned, a different invention flourished, or a different asteroid missed. In such a cosmos, what we perceive as our singular, linear history might be crisscrossed with the faint footprints of these visitors, unexplained archaeological finds, artifacts that seem technologically out of place, or historical records describing impossible encounters could be reinterpreted not as myths or hoaxes, but as traces of cross-temporal migration. A complex gear mechanism found in an ancient shipwreck, a legend of sky beings bringing knowledge after a great flood, or a sudden, unexplained shift in a culture's development might be the subtle echoes of a refugee civilization quietly integrating into a new timeline, careful not to disrupt the local flow of events too violently. This theory weaves together hard physics and boundless narrative, suggesting that the mysteries of our past may not be locked doors, but windows into a multiverse teeming with stories, where every possible history is not just a theory, but a territory someone or something might call home. The idea of our reality as a projection from a simpler surface sounds like science fiction, yet it emerges from the deepest puzzles of black holes and quantum gravity. This is the holographic principle, one of the most radical theories in modern physics. It proposes that all the information needed to describe everything within a three-dimensional volume, every star, planet, and person, can be perfectly encoded on its two-dimensional boundary, like a cosmic hologram. Think of a credit card's holographic sticker, a flat surface that creates the stunning illusion of depth when light hits it just right. The holographic principle suggests our rich, three-dimensional universe of depth and time might be a similar kind of projection, emanating from a vast, flat informational surface at the edge of everything we can see. If this is true, then time itself, the relentless flow we feel, may not be a fundamental feature of reality. Instead, it could be an emergent property, a dynamic pattern that arises from the way information is processed and updated on that fundamental boundary layer. This reframes the very nature of existence from a universe of things to a universe of data. In such a framework, causality transforms. The chain of cause and effect is not a sequence of physical events, but a logical processing of information on the cosmic hard drive. The past is not a vanished place, but a set of stored data. The future is not unwritten, but a set of potential states yet to be rendered. Time travel, then, becomes less about navigating a river and more about rewriting source code. To alter the past, a being with sufficient understanding would not need a machine that warps spacetime. They would need access to the cosmic boundary, the projector, and the ability to edit the informational patterns that, when projected, create our experienced timeline. This places the ultimate mystery of time firmly within the realm of cosmic computation. Our lives, our history, the entire sweep of cosmic evolution could be the output of an unimaginably complex calculation happening on a two-dimensional screen at the edge of reality. This idea dissolves the paradoxes of time travel into questions of data integrity and processing power. Could a change be made without creating a fatal error in the cosmic program? Would the system simply reboot to a consistent state, or would it crash entirely? The holographic principle does not offer a blueprint for a time machine, but it offers something perhaps more profound, a new language for understanding what time might actually be. It suggests that the deepest truths of our universe are not written in the language of forces and fields, but in the silent, shimmering code of information projected into the grand illusion we call reality. The holographic universe is a projection of data, but what if the data itself is being written in both directions at once? The 20th theory plunges us into the heart of quantum mechanics, where the clean arrow of causality dissolves into a two-way conversation. This is the radical idea of retrocausality in quantum experiments, where effects in the future can reach back and influence causes in the past. It is not science fiction, but a serious interpretation of some of the strangest results ever recorded in a laboratory. Take the famous delayed choice quantum eraser experiment. In this setup, a single photon is sent toward a barrier with two slits. Its behavior, whether it acts like a particle going through one slit or a wave going through both, is not determined until long after it has passed through the barrier. A choice made by a scientist in the present about how to measure the photon appears to retroactively dictate how that photon behaved in the distant past. It is as if the photon's history remains fluid, a set of possibilities, until a final observation in the future locks it into a single, consistent story. Interpretations like the transactional model of quantum mechanics take this idea even further. They propose that quantum events are not one-way transactions, but agreements negotiated between the past and the future. A particle emitted from a source sends out an offer wave forward in time. A detector in the future sends a confirmation wave backward in time. The actualized event, the particle being detected, is the handshake where these two waves meet. In this view, every quantum event is a tiny loop in time, a closed circuit of mutual agreement. This does not mean you can send a message to yesterday with a laser pointer. The effects are subtle, probabilistic, and confined to the quantum realm, but the philosophical implication is earth-shattering. It suggests that at the most fundamental level of reality, the distinction between cause and effect is not absolute. The future is not a blank slate waiting to be written by the present. It is an active participant in shaping the present itself. Our macroscopic world of unidirectional time emerges from the statistical averaging of trillions upon trillions of these timeless quantum handshakes. We experience a steady flow because we are too large, too slow, to perceive the individual negotiations happening beneath the surface. This theory weaves a temporal tapestry where every thread is connected not just to what came before, but to what is yet to come. It hints that the universe is not a chain of dominoes falling in one direction, but an intricate, self-consistent pattern where the beginning is subtly shaped by the end, and every moment is in dialogue with eternity. If the future can reach back to shape the quantum past, then the very notion of a singular self begins to unravel. This brings us to a deeply personal dilemma at the heart of time travel, the philosophical problem of personal identity. Beyond the mechanics of paradoxes lies a more intimate question. Who are you, really, if you come face to face with a younger version of yourself? This is not a puzzle of physics, but of metaphysics, probing what makes a person the same continuous entity from one moment to the next. Is it the physical stuff, the atoms that currently make up your body, even though they are entirely replaced every few years? Is it the unbroken chain of memories and experiences that you carry from childhood to now? Or is it something more elusive, a narrative thread that you spin about your own life? Time travel shatters these comfortable assumptions. When you stand before your past self, you are confronting a person who shares your genetics, your memories up to that point, and your potential futures. Yet you are also a separate being with experiences they have not lived, knowledge they do not possess, and a body weathered by years they have not yet endured. Are you two distinct persons, or one person existing in two places at once within the timeline? This forces us to examine the causality of consciousness itself. Your older mind contains the younger mind's experiences, plus more. If you speak to your past self, whose thoughts are they? If you give them advice that changes their path, are you causing your own future, or creating a new person who merely resembles you? The timeline may be able to technically accommodate two of you, but can your identity survive the split? This theory suggests that the continuity we rely on to say "I am me" is a story we tell ourselves, a fragile construct that depends on time's one-way flow. The moment that flow is broken, the foundation of the self trembles. It asks whether our identity is a permanent essence or a temporary pattern, a flame passed from candle to candle, easily extinguished if the wind of time shifts direction. Meeting yourself would not be a reunion, but an encounter with a living memory, a mirror that talks back, challenging every certainty you have ever held about who you are and where your story truly begins and ends. Our sense of self dissolves in the face of a past version of us, yet the very river carrying that self forward has a current powered by a law more relentless than memory. The second law of thermodynamics is the silent engine of our everyday reality, declaring that entropy, a measure of disorder, always increases in an isolated system. This inexorable slide from order to chaos is what gives us the unmistakable arrow of time we all experience. An ice cube melts in a warm room, never spontaneously reforming from the puddle. A shattered vase does not leap from the floor to reassemble on the shelf. These processes are irreversible because they increase the overall disorder of the universe, and that directionality is woven into the fabric of our existence. For time travel to the past to be physically possible, a traveler would need to do more than warp space-time. They would need to locally reverse this universal trend. Along their personal world line, the path they carve through the cosmos, entropy would have to decrease. They would need to move from a state of higher disorder back into a state of pristine, specific order, essentially unscrambling the cosmic egg. This presents a monumental, perhaps insurmountable, barrier. It suggests that building a time machine is not just an engineering challenge, but a thermodynamic rebellion. To journey backward, you would have to create a pocket of reality where broken vases piece themselves together and heat flows from cold objects to hot ones, a bubble of anti-time within the ever-spreading chaos of the universe. Some theoretical models speculate about where such a reversal might be conceivable. In a hypothetical closed universe that eventually collapses in a big crunch, the cosmic scale entropy might peak and then begin to decrease as everything contracts, potentially resetting the thermodynamic clock. More locally, the exotic matter with negative energy density required for structures like warp drives or stable wormholes might also create conditions where entropy could locally run backward, but the energy and control required are beyond any technology we can envision. This inextricably links the dream of time travel to the deepest drive of the cosmos, the march toward disorder. It implies that to master time is to master the very gradients that power all change, from the fusion in stars to the firing of neurons in your brain. The second law is not merely a rule, it is the current of time itself, and to sail against it would require nothing less than the power to calm the fundamental tides of reality. The relentless current of entropy drives time forward, yet at the level of fundamental forces, the conversation between past and future might be far more balanced. The Wheeler-Feynman absorber theory presents an elegant and profound vision of this balance, a model where electromagnetism itself is a timeless dialogue. Developed by the legendary physicists John Wheeler and Richard Feynman, this idea reimagines how charged particles like electrons interact with light. In the classical view, an accelerating electron emits electromagnetic radiation, waves that ripple outward into the future, influencing other particles they encounter. This is a one-way street from cause to effect, but Wheeler and Feynman proposed something far more symmetrical. They suggested the electron also interacts with advanced waves, ripples that arrive from the future. In this model, for radiation to be properly emitted, the entire universe must be set up to absorb it completely. It is a cosmic handshake where the past sends out an offer and the future sends back a confirmation, all to ensure no energy is left dangling, unaccounted for in the grand ledger of reality. The electron's jiggle is not just a shout into the void, it is a call that receives an answer from all of time, a guarantee that its energy will find a home. This is not a proposal for building a time machine to visit ancient Rome. It is a subtle mathematical hint that at the most foundational level, the physics governing our universe might be inherently time-symmetric. The distinction between past and future could be a consequence of large-scale statistics and boundary conditions, not a built-in feature of the laws themselves. In the quiet conversation between an electron and the cosmos, cause and effect engage in a two-way dialogue to maintain a perfect, harmonious balance. The universe, according to this view, ensures consistency not by imposing a rigid arrow, but by requiring a consensus across all of time. Every spark of light is a transaction negotiated between what was and what will be, a tiny thread in a tapestry woven from both ends simultaneously. It offers a glimpse of a cosmos where the flow of time we feel is the emergent roar of a waterfall, while at the level of individual droplets, the water is in constant, bidirectional communication, ensuring the river finds its way to the sea. The timeless dialogue of electromagnetism reveals a cosmos striving for balance, but there exist places where balance fails completely, where the equations of physics themselves break down. These are singularities, points of infinite density and curvature, the ultimate endpoints predicted at the heart of black holes. Here, gravity becomes so overwhelming that space and time, as we know them, cease to have any meaning. The cosmic censorship hypothesis proposed by physicist Roger Penrose presents a profound and elegant idea that nature has a built-in rule to hide these catastrophic failures from our view. The hypothesis suggests that every singularity is always clothed, always hidden behind an event horizon, the point of no return around a black hole. This horizon acts as a one-way membrane, a cosmic curtain that forever separates the infinite weirdness within from the orderly universe outside. By censoring the singularity, the universe protects the causal structure of spacetime on large scales. Nothing, not even information about the broken physics inside, can escape to influence events beyond the horizon. This is not just about hiding a monstrous object, it is about safeguarding the very rules of cause and effect that govern reality. For if a singularity were ever naked, if that point of infinite density were exposed to the wider cosmos, the consequences would be unimaginable. The predictable fabric of spacetime could rupture in utterly unpredictable ways. the neat chain of cause and effect could shatter, potentially allowing for closed time-like curves and violations of causality to spill out into the universe. A naked singularity would be a tier in the rulebook of physics, a place where anything could happen, including the birth of paradoxes. The cosmic censorship hypothesis therefore frames black holes not as destroyers of order, but as its silent guardians. Their immense gravity and impenetrable horizons act as cosmic containment vessels, quarantining the places where time and space lose their way. This connects the fate of causality directly to the most extreme objects in the cosmos. It suggests that the universe has a vested interest in maintaining a stable timeline, going so far as to lock away any physical feature that might threaten it behind the ultimate prison walls. In this view, every black hole is a monument to temporal order, a reminder that the smooth flow from past to future is so precious. The cosmos builds fortresses around anything that could make it unravel. Black holes guard the boundaries of causality, but the most intimate frontier of time lies within our own minds. The 25th theory ventures into speculative and profound territory, asking if the river of time flows not through the cosmos, but through consciousness itself. Some philosophical and theoretical perspectives propose that the flow of time is not an external, physical phenomenon like gravity, but a product of conscious observation. In this view, the relentless march from past to present to future is a story generated by the mind, a narrative framework we impose on a universe that might, at its core, be timeless. Causality, then, becomes less a law of physics and more a logical structure we use to make sense of our experiences, connecting events into a coherent plot. This idea, while far outside the mainstream of testable physics, touches on the hard problem of consciousness, the mystery of why and how we have subjective experience at all. It suggests that our perception of time is the very fabric of that experience. If this is true, then the concept of time travel transforms dramatically. It might not require a machine that warps space-time, but a shift in the very mode of perception. A sufficiently advanced or differently structured consciousness could, in theory, reorder its perception of cause and effect. It might experience the events of its life not as a linear sequence, but as a landscape where any moment could be visited, like turning to a favorite chapter in a book, or even experiencing multiple chapters at once. Imagine a mind that could perceive the acorn, the sapling, and the ancient oak as a single, interconnected entity, feeling the cause and the effect simultaneously. For such a consciousness, the paradoxes of time travel would be problems of narrative consistency, not physics, challenges of integrating experiences into a stable sense of self. This places the ultimate mystery of time squarely within the observer. The universe presents a stage of events, but it is the light of awareness that creates the spotlight, moving from one moment to the next and giving us the profound, inescapable sensation of now. It asks a question that science alone cannot answer. Is time the stage upon which consciousness dances, or is consciousness the choreographer that gives time its dance? A timeless consciousness might perceive all moments at once, but to physically bridge those moments, we need a tunnel through the fabric of reality itself. The equations of general relativity provide a breathtaking blueprint for such a structure, the Einstein-Rosen bridge, a theoretical shortcut through spacetime more commonly known as a wormhole. Picture the universe not as a flat sheet, but as a vast, flexible fabric. If you wanted to travel from one point to another far away on this fabric, the long route is to traverse the entire distance across the surface. But if you could fold the fabric, bringing those 2 points together, you could punch a hole straight through, creating a tunnel that bypasses the long journey entirely. That is the essence of a wormhole, a cosmic subway connecting distant stations in the cosmos. The profound twist, however, is that in relativity, space and time are woven into a single entity called spacetime. A tunnel that connects 2 points in space could, under the right conditions, also connect 2 points in time. The key lies in how you manipulate the mouths, the entrances and exits of the wormhole. Imagine you could take one mouth of a newly formed wormhole and place it on a spaceship. You then send that ship on a journey at a significant fraction of light speed, or park it near an intense gravitational field. Due to relativistic time dilation, time would pass more slowly for that traveling mouth. After a year of ship time, you bring it back to rest next to the stationary mouth. For the stationary mouth, a decade might have passed. Now, you have a tunnel where one end is a year in the past relative to the other. Step through from the older, stationary side, and you would emerge 1 year into your own past. Step through from the younger, traveling side, and you would leap 9 years into your future. This is not magic. It is a direct consequence of Einstein's own rules, a way to engineer a time machine by cleverly manipulating the geometry of the universe. The wormhole transforms causality from an abstract principle into a question of cosmic plumbing. It suggests that the arrow of time could be bent into a loop not by breaking the laws of physics, but by using them to construct a bridge where cause and effect can meet in the middle. Yet this elegant solution comes with its own profound warnings, for a bridge that connects different times also opens a channel for paradox, a direct line where a signal could be sent to its own source, creating a feedback loop that could shatter the tunnel's delicate structure. The wormhole's delicate bridge is a marvel of cosmic engineering, but what if the universe it connects is not the base layer of reality? The simulation hypothesis presents a staggering possibility, one that redefines the very nature of time and causality. If our reality is a sophisticated simulation, akin to an unfathomably complex video game running on a computer in a higher-order universe, then time is not a fundamental dimension. It is merely a variable in the code, a counter that increments to create the illusion of progression. In such a framework, the river of time is not a physical current, but a data stream. Every moment from the Big Bang to this instant is not a vanished past, but a saved state on a cosmic hard drive. Time travel, then, would not require warping spacetime or navigating quantum loops. It would be a matter of administrative access. To revisit the past, the operators of the simulation could simply load a previous save file, rewinding the universe to a prior configuration. To leap forward, they could fast-forward the processing, skipping millions of years of calculation in an instant from our perspective. Causality itself transforms under this lens. The unbreakable chain linking cause to effect is not a law of nature, but a programmed rule, a subroutine designed to ensure the simulation runs in a coherent, predictable manner. It is the algorithm that ensures a dropped apple falls, that a lit fuse leads to an explosion. But just as a programmer can alter the rules of a virtual world, the operators could, in principle, override this subroutine. They could introduce a glitch where an effect precedes its cause, or create a closed loop where an object is its own origin, simply by editing the underlying code. This perspective reframes every temporal paradox we have explored not as universe-breaking contradictions, but as software anomalies. The grandfather paradox becomes a conflict in the narrative logic check. The Bootstrap Paradox is a recursive function with no base case. The butterfly effect is an example of sensitive dependence on initial conditions within the simulation's physics engine. Even the mysterious, non-local connections of quantum entanglement could be seen as a programming optimization, where two distant objects are linked not by a hidden force, but by a shared pointer in the code. This theory does not answer how time works, but it radically recontextualizes the question. The laws of physics we dedicate our lives to studying become the observed behaviors of the simulation's algorithms. The arrow of time, driven by increasing entropy, might be a necessary feature to prevent memory overload, a garbage collection process for the cosmos. The simulation hypothesis offers a chilling and awe-inspiring conclusion. The ultimate nature of time, and whether it can be traversed, depends entirely on the architecture of an external reality we cannot perceive, and the intentions of beings whose motives we cannot begin to fathom. These digital speculations feel utterly modern, yet the yearning to understand time's loops is ancient. Across millennia, long before equations and quantum theories, human cultures wove the fabric of time into the very heart of their myths and legends. This is not coincidence, but a profound reflection of a deep intuition, a sense that the river of time might have whirlpools and eddies hidden beneath its smooth surface. Consider the vast cyclical ages described in Hindu cosmology, the yugas. Here, time is not a line but a great wheel, turning through golden, silver, bronze, and iron ages in an endless cycle of creation, preservation, and dissolution. The universe itself breathes in and out, with each cycle containing echoes of the last, a grand, recurring story where cause and effect spiral rather than march. Or look to the Norse world tree, Yggdrasil, whose roots and branches connect different realms, including the Well of Fate and the dwelling of the Norns, who weave the destinies of gods and humans. This is a map of a layered, interconnected reality where past, present, and future might exist simultaneously, accessible through sacred pathways. These are not primitive guesses, they are sophisticated narrative models for a non-linear cosmos. These archetypal stories often grapple directly with the puzzles of causality we now analyze with mathematics. The tale of Oedipus in Greek tragedy is a stark exploration of a predestination paradox, where every frantic effort to avoid a prophesied fate becomes the very mechanism that ensures its fulfillment. Prophetic dreams, a staple from ancient epics to indigenous traditions, present information flowing backward from the future, challenging a simple one-way arrow. Legends of heroes descending into underworlds or sleeping for centuries speak to journeys that distort personal time relative to the world, a mythological form of time dilation. What these diverse narratives reveal is a universal human fascination with the fragility of cause and effect. They allowed cultures to explore the emotional and philosophical weight of paradox, the terror and wonder of a mutable past, long before the concept of a closed time-like curve was ever scribbled on a blackboard. This rich tapestry of myth reminds us that the mystery of time transcends laboratory walls. It is a fundamental strand in the story of what it means to be human, to remember a past, inhabit a present, and fear or hope for a future. Our ancestors used the language of gods, heroes, and cosmic trees to map the very territories modern physics now probes with telescopes and particle colliders. They understood intuitively that time is not just a measure on a clock, but the very stage for destiny, memory, and meaning. These ancient stories do not give us blueprints for machines, but they offer something equally vital. A testament to the enduring human spirit that looks at the relentless march of days and dares to dream of a path that leads back or a doorway to a different tomorrow. They tell us that our quest to understand time is, at its heart, a quest to understand our own place within the infinite. The ancient myths remind us that tampering with time was never just a technical challenge, but a moral one. Moving from legend to potential reality, we arrive at a theory that grounds the entire discussion in a stark and necessary question of conscience. The ethical implications of time travel present a quagmire far more complex than any paradox. If you held the power to step into history, what moral responsibilities would you carry? This is not merely about what you could do, but what you should do. The first and most agonizing dilemma involves historical intervention. Imagine standing on a street corner in a city on the brink of a terrible conflict, with the knowledge to prevent a catastrophic event. The human impulse to alleviate suffering is powerful, almost irresistible. Yet, acting on that impulse unravels a thread of causality with consequences no mind could fully calculate. Preventing that conflict might save millions from hardship in the short term, but it could also erase the conditions that led to the births of countless individuals in the future you call home. Every descendant born from unions that would never happen, every innovation born from necessity in the aftermath, every cultural shift forged in resilience could vanish in a new, peaceful, but utterly unfamiliar world. Are you responsible for the suffering you see before you, or for the potential lives, however unknown, that your own present depends upon? This is the terrible weight of playing architect with time, where a single act of compassion could be an act of annihilation for generations you will never meet. It introduces a chilling ethical category, the rights of potential persons across different timelines, possible people whose existence hinges on a specific chain of events, have a moral claim that a time traveler must respect. Or does the duty to prevent tangible, immediate harm override the abstract potential of future lives? There is no clean answer, only a collision of profound values. This forces a secondary duty, a loyalty to your own timeline. Your memories, your relationships, your very identity are products of a specific history, with all its beauty and all its scars. Do you have an ethical obligation to preserve the sequence of events that made you and your loved ones possible? To change it is, in a very real sense, to consent to your own non-existence, or at least to the erasure of the person you are. You would become a ghost in a world you engineered, a stranger to everyone you once knew. This demands the development of an entirely new framework, a temporal ethics. Guiding principles would be needed for any would-be chrononaut, rules that might include non-intervention, or perhaps only allowing observations that do not alter the causal chain. It might require accepting that some historical hardships, as tragic as they are, form the bedrock of the present and must remain untouched. The power to change time is ultimately the power to unmake the world, and with it, the ethical burden to know when that power must remain forever unused. The profound ethical weight of changing time forces us to look beyond our moment, to the very horizon of existence. Our final theory asks what becomes of cause and effect when the universe itself reaches its end. In the far future, trillions upon trillions of years from now, the cosmos may face one of two ultimate destinies: a slow, cold dissipation known as heat death, or a violent collapse in a big crunch. In either scenario, the nature of time and causality would undergo a transformation so profound it challenges the core of our understanding. Heat death paints the more haunting picture. The universe expands forever, stars burn out, black holes evaporate, and all energy becomes evenly distributed in a vast, lukewarm sea. In this state of maximum entropy, there are no temperature differences, no energy gradients, no structures left to form or change. This is a cosmos where nothing happens, and if nothing happens, what use is an arrow of time? The relentless drive from order to disorder that gives our reality its forward thrust would have nowhere left to go. The river has reached the ocean and the current simply stops. In such an epoch, the concepts of before and after could lose all meaning. With no processes to distinguish one moment from the next, the universe would enter a state of timeless equilibrium. Causality, the beautiful chain linking one event to another, would have no events left to link. It would be a silent, static tapestry with no story left to tell. The very possibility of time travel, which relies on a dynamic spacetime with a discernible direction, would evaporate. There would be no past to visit, no future to leap toward, only an endless, undifferentiated now. The alternative, a big crunch, offers a different but equally mind-bending finale. If the universe's expansion reverses, everything races back together toward a singularity of infinite density. As the cosmos contracts, entropy might theoretically begin to decrease. The thermodynamic arrow of time could reverse. Shattered vases would reassemble, scattered light would converge, and the universe would seem to run in reverse from our current perspective. But in this frantic, backward rush toward a single point, the distinction between cause and effect would become utterly scrambled. An effect in the collapsing phase could be the cause of something in the expanding phase, creating causal loops that span the lifetime of the cosmos. In the final moments before the singularity, the extreme conditions could make closed time-like curves not just possible, but inevitable, twisting causality into knots before everything is dissolved into a state where physics and time have no meaning at all. This ultimate theory ties the destiny of causality directly to the fate of the cosmos. It suggests that time as we know it, with its clear flow and unbreakable rules, is not an eternal, fundamental feature of reality. It is a transient phenomenon, a phase the universe goes through during its vibrant, structured middle age. It emerges from the drama of forming galaxies, living stars, and thinking minds, and it may fade away when that drama concludes. Our entire discussion of paradoxes and possibilities exists within this golden window of cosmic history, a window where change is still possible and stories can still be told. This final perspective is both humbling and strangely beautiful. It means that the precious, irreversible flow of our lives, the chain of choices and consequences that defines us, is a gift granted by a specific, fleeting state of the universe. It asks us to consider that the river of time may not be forever, and that makes every moment we navigate its currents, every cause we set in motion, and every effect we experience infinitely more meaningful. Our journey through these 30 mind-bending theories reveals a stunning truth. They are not separate islands of thought, but points of light on a single, vast constellation. The rigid, self-healing timeline of Novikov's principle and the infinite, branching possibilities of the many worlds interpretation are not opposing ideas. They are different answers to the same cosmic question of how reality handles change. The quantum whispers of retrocausality, where the future tugs on the past, and the majestic scale of the holographic principle, where time is a projection, are simply different levels of magnification on the same mysterious fabric. Each theory, from the personal horror of the grandfather paradox to the cold equations of thermodynamics, shines its own unique light into the darkness, illuminating a different facet of the same impossible gem. Together, they paint a portrait of time and causality that is infinitely richer and more bizarre than the simple, linear arrow we feel in our bones. They exist on a breathtaking spectrum, from the frozen, predetermined sculpture of the block universe to the fluid, emergent story generated by consciousness itself. This synthesis tells us that the true nature of time is likely not captured by any single theory, but lives in the spaces between them. It may be that our universe operates with a kind of layered logic, where quantum particles engage in timeless handshakes, while larger objects are swept along by the thermodynamic current, all within a cosmic structure that permits both stable history and fleeting loops under conditions of extreme gravity. The search for a unified theory of time is not about choosing one idea over another, but about discovering the deeper framework that makes all of them possible, the fundamental rules from which both rigidity and fluidity, causality and paradox can naturally emerge. The grand tapestry of time is still on the loom, and we have only just begun to trace the pattern of its threads. From the timeless whispers of quantum particles to the ultimate fate of the cosmos, these 30 windows into possibility reveal a universe far stranger than we ever dared to dream. Our journey has woven through the rigid logic of physics and the boundless realms of philosophy, tracing the contours of a mystery that lies at the very heart of existence. We have navigated paradoxes that twist the mind, confronted dilemmas that challenge the soul, and glimpsed architectures of reality where time is not a river, but an ocean with currents flowing in every direction. Each theory, from the self-healing timeline to the branching multiverse, is a testament to human curiosity, a brave attempt to solve the eternal puzzles of change, identity, and consequence. They are not mere abstract games for intellectuals, but profound explorations that push the very boundaries of what we can know. They compel us to look at the night sky, at the history in our books, and at the moments of our own lives with a renewed and humbling wonder. The true value of this exploration lies not in finding a single answer, but in learning to ask better questions. So, which of these visions resonates most deeply with you? Does the elegant consistency of a single timeline feel right, or does the infinite freedom of parallel worlds spark your imagination? Share your favorite theory in the comments below. Let us continue the conversation. If these deep dives into the mysteries of space and time have expanded your perspective, consider subscribing for more journeys to the edges of understanding. The universe is a story still being written, and the final mystery of time, like all great stories, awaits your endless curiosity.